Okay, so I was talking to Sean a little bit earlier today, and one of the things he was saying was, I didn't know how to pick the right test. That's kind of what the quiz was, right? And it's going to be the hardest part of tomorrow's or today's test, if you're taking it today. And the hardest part of the final is picking the right test. The final is going to be heavily weighted towards hypothesis tests, because that's what statistics is all about. Can you interpret it properly? Can you pick the right test? So, so just as a reminder, if you go back to your notes, the first day we did hypothesis testing was the first day of chapter 10, and I gave you that big outline. It's going to make a whole lot more sense now. Okay? So, so you might want to check that out. But that will be very, very helpful. So anyway, now it's your turn. What questions do you all have? Yes?
We'll go over what you need to put into an F test. Just like looking at the diagram, I think we got
what you need to look into an F test. So you're talking about a 2-sample standard deviation. Because, oh, by the way, next week we're going to do another F test. So you don't need to know about it. And in fact, the one thing that I will say, by not putting it on this test, it made that quiz a little bit easier. Some of you would have picked the ANOVA test instead of the chi-square independence test. You still missed it anyway?
I still don't know. I don't know what ANOVA test.
Yeah, I know, because they haven't learned it yet, but we'll learn it on Monday. All right, so it's hard for me to come up with a question. You want me to just pull one up, Tyler? Let me just pick a question out of the book, and we'll try to.
That would be awesome.
Okay. Except since I'm picking it, then everybody's going to know it's an F test, but that's all right. I guess the question will be, how do we know it's an F test? So let me see if I can find one here. I'll pull up Excel. All right. Oh, actually, 11.5. I didn't notice that. It's titled, "Which method do I use?" That might be a good thing to study. Although it's mostly a chapter 11 stuff. But okay, so here we go. We'll do this one. This might take the rest of the class. QC, this is problem 20, page 575. A QC, yeah, sorry, you're going to want that bigger, aren't you?
It's not on.
Oh, it's not on, that would help. A QC engineer wants to find out if the new machine has less variability than the current machine. She randomly selects 15 bottles and obtains following results. So I got old, I got new. All right, 16, 1604, 1610.
What page is this?
This is on page 575. So we'll treat this as if we don't know what kind of test it is, although we kind of gave it away already. All right. So, if you want to take it away, what should we ask first?
Doing that test.
If we were doing this fresh, you wouldn't say that though, right? If we're doing this fresh, what would be the first question you should ask yourself? Is it categorical, quantitative, or regression? And you would say quantitative because why? They're not binomial. Because they're decimals, probably. That'd be a good reason. Okay? Now, next question you might want to ask yourself is what? Before that, is it big enough? Is it big enough? 15 times, or 15 plus 15 is 30, right? So is it big enough? No. No, because it's only 15, right? Okay. So we're going to assume it's normally distributed anyway, but you know what I've noticed about this book? Especially if I threw this on the final and I said, oh, do your QQ test, and it would be not normal, and you'd be like, oh. And then you just say, well, it's not normal, but I'm going to do it anyway. Okay. And this book has a terrible habit of giving you non-normal data, but assuming it's normal. Okay. So anyway, just keep that in mind. Okay. So it's not big enough. How big should it be? Should be greater than or equal to 30. Well, it's only 15, right? Got two sets of 15, so it's too small. Okay?
So,
Yeah.
What you're saying is, if we have an issue like that, we will say, who's writing the test, this is not big enough, but we're gonna assume that this is, and we're gonna keep going with it.
We're going to keep going with it anyway. Yeah.
So we
But
don't
yeah,
know.
you should note that it's not big enough. Or honestly, if it's on the final, I'll probably just say do a QQ plot. I won't make you do that on this test because it'll take like 10 hours anyway, right? Somebody took 5 hours on that last test. Was that you? Okay. Holy cow. Yes. Yes, you have to do two QQ plots in this case. Okay? All right, so just keeping that in mind. Okay, we're going to assume it's normal because we've only got 10 minutes left. Okay, so now the type of test, is it a Z, a T, a chi-square, or an F? And how do you know, more importantly? We know it's an F because Tyler asked for an F, but how do you know it's an F? What'd you say? Not just one if it was one variability, what would it be? It would be a chi-square, right? Since it's two, it's an F. It's an F of two chi-squares divided by each other. Okay? So it's an F, two standard deviations, right?
So we use F if there's more than one variable.
Yes, and in fact, just, oh, by the way, okay, preview of Monday, we're going to be doing F again, okay? We'll see who remembers this over the weekend. And you're going to be doing 3 or more means, okay? So not just 2, we're going 3, okay? All right, so now, what's our null hypothesis and our alternative hypothesis? Sigma 2, the alternative, or here, let's do it this way. Instead of sigma 1, there's nothing wrong with sigma 1, sigma 2. But to be more explicit, let's do sigma old equals sigma new. Because that's going to make your thing a little bit better. Okay. She wants to know if the new machine has less variability. Yeah. So this is actually greater than, we want the old to be greater than the new. I should have done a less than. I should have done new less than old, but whatever. Whether you want sigma old greater than sigma new or sigma new less than sigma old, it doesn't really matter as long as you do it right. The way I've written it, it's a right tail test. You could do this as a left tail test. Okay? All right, now, what's the next step? Yeah, find the test statistic. The equation is actually quite easy, right? F equals S1 squared, or maybe we should say S old squared, because we're calling that one 1 squared, divided by S new squared, right? Okay. So of course, what do I need to find out now? I need to find out the standard deviation. Now, here's what I would recommend. You probably also want to find the mean. Wouldn't it be interesting, even though you don't need it for this problem, wouldn't it be interesting to see if the new machine was not, because the label claim is 16 ounces. Oh, that's pretty close. That's really close, okay? So both of them are filling up the machines properly. But we're trying to check the variability of both of these. So what do you guys think? Does it look like the new machine's better than the old? Yeah, maybe slightly. It's a 0.04 versus 0.07. Is that a big difference? We're going to find out, right? Okay, what'd you say? Oh, okay. All right, so now S score is going to be the old squared. Old squared. So this number squared divided by this number squared, which is 2.73. Okay, now what? What'd you say? I need to find the p-value. How do I find the p-value? F this right-tailed. Now, they probably, you could do this one as a left-tailed test, but the way we set it up would be a right-tailed test. What? It's definitely easier to do the right-tailed. Okay? What do I put in for X? The 2.73. Degrees of freedom 1? 14. Degrees of freedom 2? 14. 0.03. What's my alpha? Oh, it didn't give me an alpha, did they? No, they did in part A, but I didn't write it down. But yes, it actually is what we would think it would be. Okay, yes?
So you can make this a right tail test by switching the first and second sigma.
Yeah, so if we wanted to do this as a left-tailed test, we could switch these around. So if I did this squared divided by that squared, it's now a left-tailed test, and I can do f dot dist. And of course, I would have to swap my degrees of freedom, but luckily they were equal, so it didn't matter. Okay, comma 14, comma 14. Otherwise, I'd swap those. Well, you can see I swapped them. Okay. And let's see, hopefully we get 0.034. Oh, I got it. Is it true or false? True. How about that? Okay, so you could do it either way. Okay. And so therefore, Charles, what's the conclusion?
So it's less than 105 centimeters.
All right, yeah. You were smarter than me. Reject, no. And now your conclusion is?
In conclusion, there's enough evidence that the old machine has less variability than
Greater. Remember the old machine's 0.07, this is 0.04. There's greater variability
greater variability.
than the new machine. Okay? Yes. How would you find the confidence interval? I don't think we can find that on the F test, can we? Ah, that's a good question though. Can you find the confidence interval for that? I don't think you can.
No,
That was chapter 11.
it's not the equation sheets and cost.
Yeah, we don't have a formula for population standard for two. We do for one, but we don't have it for two. So if I ask you for a confidence interval, what are you going to say?
No way.
No way, Jose. Okay? And I could do that. So
I'm writing that.
don't put it past me.
I'm writing
Okay?
I just read that.
Don't leave it blank. If you leave it blank, I'll be like, oh, they didn't know what to do. Okay? Say there is no confidence interval. Okay? It's on recording now. If you leave it blank, you're going to get it wrong. If you say there is no confidence interval, you'll get it right. Okay? All right. Any other questions? Yes.
This is over 11.2 to 12.
11.1. Remember we split up 11.1. So yeah, chapter 11 and 12 basically. So by the way, I hope, who's planning on taking it today? Okay. So I went to check and make sure the password was okay and the website was down. So hopefully I remember what the password that I put there, but they may need to call me. I'm not going to be available today, so I'll try to, hopefully that's okay. I'll check it again, but when I checked before, I was like, oh. All right, see y'all tomorrow. Good luck.